Welcome to Study Loop.
So we will now talk about Chapter 17, Problem 156. Here, this is meant to be worked on as a group. It says to have each group member look up the KSP for a different compound and calculate the molar solubility. And then it asks a question, do the numerical values suggest that the compound is soluble or insoluble? And compare with what we know about solubility rules. So the answer will be different, obviously, depending on the compound that you choose. I'll go ahead and work with two ionic compounds just to give an example of what this might look like. So the KSP of silver chloride is equal to 1.77 times 10 to the minus 10. So if we were to calculate the molar solubility here, the KSP would be equal to S squared. And then if we calculate for S, we get S is equal to 1.33 times 10 to the minus 5 moles. And then we can do for a second one, let's say calcium chromate. So the KSP for calcium chromate is equal to 7.1 times 10 to the minus 4. And so this is equal to S squared. And we can solve for S by taking the square root and getting 2.66 times 10 to the minus 2. So we can see that from these two examples, this problem is more, this compound is more soluble, whereas silver chloride is less soluble. Now, if we think of things when we first learned solubility rules, we thought of things as being soluble or insoluble. So neither of these compounds is as soluble as something like sodium nitrate or sodium chloride, things that we consider to be always soluble. However, we can see that when silver chloride's concentration gets to be above, it gets to be in the micromolar range, a precipitate will start to form. So it is a relatively insoluble compound, whereas calcium chromate is more soluble. We can have higher concentrations in solution, up to 2.66 times 10 to the minus 2.